my KCET 2025 champions. So yes, welcome to the Master Stroke KCET class, and today we are going to discuss one shot of amines. Okay, so in this lecture everything will be covered regarding amines. I'll be telling you the preparation method, the chemical reactions, the basicity, the one which confuses you so many times, right? And also some important questions are also included. So yes, please stay tuned for the whole class. Sit with a notebook and a pen, watch the complete video, and I will also be telling you the secret of making flow charts for different reactions, and you should also be preparing with me. Okay, so that's all students, that was the intro part, and you know whatever things we are going to do, this is going to be your game changing episode, game changing series for your KCET 2025 preparation. You can just watch this one shot video which I will think will be covered within 1 hour 15 minutes maximum, and this one shot can sort like all your problems. Okay, so please share it with your friends, like and subscribe the channel so that you do not miss any of these videos. Okay, now let's get started with the first thing. So I'll be telling you what all things we are going to do in this particular chapter. Okay, so there are basically two main components of this chapter. One is your amines, another is your diazonium salts. So for amines we will be studying the preparation method, physical properties and chemical properties. Similarly, for diazonium salts also we will be studying the preparation and the physical properties and the chemical properties as well. So for every organic compound this is same. Okay, whichever functional group you study, this is constant, where you have to study the structure, or I can say the preparation, then you have to study the physical properties, and then you have to study the chemical properties. So generally if you see haloalkanes and haloarenes, so we see there, okay, haloalkanes is there, haloarenes is there, alcohols, phenols, ethers, aldehydes, ketones, carboxylic acid. But in amines we just write amines, but yes, there is one more hidden component in that, that is your benzene diazonium salts. Okay, so now moving forward, now let us see the weightage year wise of this chapter. Okay, so this has been for the last the last from 2024. You can see 3 to 4 marks questions have been asked. But yes, one thing that you should remember is for every question, since the number of chapters have been decreased this year, right? So every chapter you can expect 4 to 5 questions. Okay, easily you can expect 4 to 5 questions from this chapter. Now let us move forward here and see the structure of this one. So the structure is like nitrogen, okay, and then you have ammonia. It is a pyramidal structure where the general structure is tetrahedral, okay, and then you get a tetrahedral structure, and then you have two lone ones. One of the orbital, it is sp3 hybridized, and you have in one of the pair lone pair is there, and in all other three it is hydrogen. Okay, so now talking about the structure of ammonia. Okay, so see, ammonia has like a pyramidal structure. Okay, it has like 4 sp3 orbitals. So we have one sp3 orbital here and the 3 sp3 orbitals are here. So we have hydrogen, and each of these sp3 hybrid orbitals bonds with one hydrogen. So now what happens, in one of the sp3 orbital there is one lone pair of nitrogen. Okay, so that shape is like the if there would have been no lone pair, it would have been tetrahedral shape, but due to the lone pair, due to the repulsion, what we get here is a pyramidal shape. Okay, now coming to the next one, classification. This is very important to understand the classification. We generally get confused. Even when I was a student, I used to get confused with primary, secondary and tertiary amines. So but very simple, see, you have to see that this nitrogen is present. Okay, it has 3 bonds. If this nitrogen is attached to, like 2 are hydrogen and 1 is carbon, attached to only 1 carbon, then we call it primary amines. If it is attached to 2 carbons, then we call it secondary amines. Now if we attach to 3 carbons, then it is called tertiary amines. Okay, so now if you know primary, secondary and tertiary amines, so we represent it like this: RNH2, okay, then we have R2NH, and we have R3N. Okay, so that is primary, secondary and tertiary amines. Fine. Now moving to the next thing, that is after classification. we will see here nomenclature. So now nomenclature is also little bit different from the normal nomenclature that we do. See, the common name you can write easily, the ending should be amine, like ethyl amine, propyl amine, isopropyl amine. You can, this is how primary amines are named. And how does the IUPAC name ends? It is with ethanamine. Okay, so you have ethanamine. Okay, amine, amine, it will end like this, where you have to mention the position on which the NH2 group is attached. Okay, now coming to this one, you have here ethyl meth. Okay, now when it is a secondary, you can say this nitrogen is attached to 2 carbon, right? So it is a secondary amine. So now you have N-ethyl. Okay, how the IUPAC name will come? N-ethyl. Okay, so sorry, N-methyl and then ethanamine. The parent name will be on the carbon which is having more number of carbons. And what will be its common name? You have to just name it alphabetically order: ethyl, methyl, amine. Now here you see we have 3 CH3 groups, so I will write like NN dimethyl, okay, methanamine. NN dimethyl methanamine. Okay, and what will be the common name here? Trimethyl amine. Next we have here, you can see here one side it is butane, one side, 2 other sides are ethyl group. So you can write NN diethyl butyl amine. Okay, NN diethyl butyl amine. And what is the IUPAC name here? NN diethyl butanamine. Okay, so here it is butyl amine and here it is butanamine. Okay, now we have this one. Here you can see 1, 2 and 3. So this is allyl amine. Why I am calling it allyl? See, the carbon to which the NH2 group is attached, that is directly attached to an sp2 carbon, right? And here what we have here is prop 2en1 amine. Okay, propinamine. Okay, similarly here we have hexamethylene diamine. Okay, the common name hexamethylene diamine, or you can name it as hexane 1,2-diamine. Okay, that is how you should name it. Now moving forward towards the nomenclature of the aromatic rings. So if you have only NH2 group, we call it aniline or benzenamine. Here it is called, you know, this CH3 group it is present, we call it toluidine, right? So now we have orthotoluidine or we have 2-methyl aniline. Similarly, you have para-bromoaniline, okay, para-bromoaniline or 4-bromobenzenamine, 4-bromoaniline. Okay, next we have here NN dimethyl aniline, or you can write NN dimethyl benzenamine. Okay, fine. Now moving to the next one, we have classified the following as primary, secondary and tertiary amines. Okay, so how will you do this? See, you have one thing, you have to just check to this nitrogen how many carbons are attached. To this one nitrogen there is only 1 carbon attached, so it is primary. To this nitrogen you can see 3 carbons are attached, so it is tertiary. To this nitrogen directly one carbon is attached, so it is primary, and here we have 2 carbons, so it is secondary. Okay. Now coming to the first topic, that is preparation of amines, very important. So what are the methods? Let us first see. So I want all of you to draw this structure. Okay, this is very important. So first one is reduction of nitro compounds. Okay, reduction of nitro compounds. Second thing we have is the ammonolysis of alkyl halides. This is also very important. Reduction of nitriles, reduction of amides. So how will you remember? There are 3 reduction reactions. What are they? Reductions of nitro compounds, reductions of nitriles and reductions of amides. Okay, 3 nitrile reductions are there. Then you have ammonolysis of alkyl halides. Ammonolysis of alkyl halides. Now coming to Gabriel phthalimide synthesis and then Hofmann bromamide degradation. Okay, these are the 5, I can say 6 methods of preparation. What is this? 3 reduction, can you remember? There are 3 reduction methods. What are they? Reductions of nitro compounds, nitrile compounds and reductions of one thing I see, I am also not able to recall, I am not saying it. Okay, so reductions of nitro compounds, reduction of nitrile compounds, reduction of amides. Okay, these 3 I got. Then Gabriel phthalimide, Hofmann bromamide. Okay, and one more was there, ammonolysis. So I got 6 preparation methods. Now let us study them in detail. Okay, what are the reagents used for each of them? So first one was what? Reduction of nitro compounds. So I am starting from here. Reduction of nitro compounds, how can you do? Using SnHCl or FeHCl or H2 palladium ethanol. So there are three reagents that we can use here: SnHCl, FeHCl or H2 palladium ethanol. That is the first thing. Okay, so this is your first method, reductions of nitro compounds. Second is what? Reduction of nitriles. Okay, ammonolysis. So I will explain this ammonolysis part in detail first. Okay, see how does ammonolysis take place. See, you have here Rx, okay, and you are treating it with ammonia. Okay, so what happens here? Nitrogen also has lone pair, right? So I can show you once. Wait, once. Okay, you see this NH3 is there and Rx is there. Okay, so first what happens? Okay, it is there, Rx is there, and NH3 is there. Okay, so now this nitrogen lone pair is hyperactive. What will it do? It will attack on this R group. Okay, so now what will happen? You will get like this. You will get Rx, okay, and then we have this, this X will not be there, we can remove it, okay, and it will form NH4 plus, okay, and this X minus is also there, okay, X minus is there. Now from this what happens? Okay, NH3 is there. To this R, this NH3 group has attached and this HX part is there. Now when you treat it with NaOH, okay, so what it will get convert to? RNH2. So what exactly you are doing? You are replacing one of the hydrogen of this one with this R group. Okay, so that is there. Okay, RNH3 plus and X minus. So when you treat it with NaOH, you get one is RNH2. Then one of the product you get is H2O and one of the product is NaX. So this is your second one, that is with ammonolysis. Now third one you can see. Now after this what happens? Once you get this primary amine, again if you treat it with Rx, what will happen? One more H will be replaced with R. So what I'll get now? R2NH. If I again react with Rx, then one more H will be replaced, I'll get R3N. Again if I react, it will become R4N plus X minus. Okay, so this is called as what? Your ammonolysis. Okay, the second method, reduction of nitro compounds, ammonolysis. Then we had reduction of nitriles, right? Third one. What is the reagents? Reductions of nitriles. What are the reagents that can be used here? You can use H2 nickel, you can use LiAlH4, or you can use sodium amalgam. Okay, three things you can use: H2 nickel or LiAlH4 or sodium amalgam. Okay, so you have H2 nickel or lithium aluminum hydride or sodium amalgam to reduce RCN to RNH2. Okay, that is the third thing. Fourth one is your RCONH2. Using LiAlH4 you can convert, and in this what happens? This gets converted to RCH2NH2. Next, the Hofmann bromamide degradation. Here also amines are there. See, I'll give you an example. What is the difference between these two? It's very important to understand. Suppose you have CH3CONH2, okay, and you have CH3CONH2. This one, suppose you are treating with lithium aluminum hydride. So what is the product here? CH3, CH2 and NH2. Okay, but if you use bromine and KOH, that is your Hofmann bromamide degradation, so this CO group will go. Okay, you will get CH3 and NH2. Clear? Okay, fine. Now coming to the next one. Okay, so yes, fine. So we got how many things? 4, and fifth one is your amides group. Okay, reaction with amides. So first one is what? Reduction of nitro compounds. Reduction of nitro compounds, we are using what reagent we can use? You can use SnHCl, you can use FeHCl, or you can use hydrogen palladium in ethanol. Now ammonolysis, simple, you have to take what? Rx and ammonia. Third one, RCN, that is with nitriles. What you can use? Lithium aluminium hydride, so hydrogen nickel sodium amalgam. Okay, it is little difficult to remember this one, but these two are very common, you can use it. Next, with amides we can use LiLH4, and with amides, to reduce this CO group you will get bromine and KOH. Okay, so all the reactions are there. Next, moving to the next one, that is your Gabriel phthalimide synthesis. So here you should remember, this is used only for the preparation of primary amines, and that too aliphatic amines. Okay, you cannot prepare aniline with this. So here what happens, first we take phthalimide, then we react with KOH. So here what happens, this is my, so you don't have to remember anything here. So there is a salt formation, then here RX is taken. Next what happens, this R will come here, okay, NR is formed, then you take NaOH, then this one will be like CO minus Na plus, and then you will get your RNH2. Okay, these are the 6 methods of preparation. So can we have a quick revision of all this, of all these methods? So where is it? Yes, this one. This is the chart where you should make and you should revise using this one only. Okay, so this chart should be prepared by everyone. Okay, why am I not able to erase this? Yes, fine. So let's moving forward here. So what is nitro compound? What we will get in nitro compound? What all the reagents are there? Quickly you can also type in the comment section what all reagents we have discussed for nitro compounds. So first is your SnHCl. One second, why is this happening? Yes, okay. So we can use SnHCl, we can use FeHCl. Once I will write, I will get aside. Then you can use H2 palladium. Comment also you should put in the comment section. Okay, everyone who is watching this video, please put in the comment section. Ammonolysis of alkyl halide, simple RX plus ammonia. Reduction of nitriles, RCN. Here also we had 3 methods, LiAlH4, okay, H2 nickel or H2 palladium is also fine. This is something which I usually forget when I was studying sodium amalgam with ethanol. Next, reduction of amides, RCONH2, what will be there? Here simple, LiAlH4. Then Gabriel phthalimide synthesis is your primary amines, right? And there was one more, right? 1, 2, 3, 4, 5. Okay, Hoffman bromamide degradation, Br2 in presence of KOH. Okay, clear? Fine. Now moving to the next one, we have, okay, so here's the question, select the correct IUPAC name of the following. Okay, so you know this is a tertiary amine, so here we will be the one which is the longest chain, that will be the parent name, so it will be propanamine. Okay, so NN, so we have NN dimethyl propanamine, option number D. Very simple one. Okay, one more question here, CH3CN which H2 Rani nickel. Okay, so that is your I can say reduction of nitriles, so this one will give you CH3 CH2 NH2, that is your ethanamine, option number B. Okay, I will get what? CH3 CH2 NH2. Okay, next moving forward, this is a question, are CH3CONH2 with bromine NaOH. That means what, this CO group will be hidden. So what I'll get, CH3NH2, that is your methanamine, option number D. Okay. Next we have amines part 2, where we are going to discuss about the physical properties and chemical properties of this. Okay. So what is physical properties here? See. And also I'll talk about the chemical properties first, what all things we are going to study in this. Okay, one second. Yes. So now you can see in physical properties, we'll be talking about the solubility, basicity and all thing. What about the chemical properties? You should have a list of this. First thing we'll be talking about the basic nature. Then alkylation, acylation, carbyl amine reaction. Okay. Next we have reaction with nitric acid, reaction with aryl sulfonyl chloride, electrophilic substitution. So 1, 2, 3, 4, 5, 6, 7. 7 reactions are there. Okay. First is basicity, alkylation, acylation. Okay, these 3 I can remember. Carbylamine test is there, that I can remember. Nitric acid reaction, benzene sulfonyl chloride is also a test. Then electrophilic substitution reaction is the easiest one. Okay, so let's start with the first thing, that is your basic nature. Okay, before that I'll just discuss the physical properties. So what is there in physical properties? Solubility. So solubility is in water will be more because they are able to form hydrogen bonds with the water, that is there. Now lower aliphatic amines are soluble in water because they can form hydrogen bonds with water molecules. However, solubility decreases with the increase in molar mass. So this is common to everywhere. Whenever the molar mass or whenever the aliphatic chain or the hydrophobic part of any compound increases in size, the solubility will decrease. Okay, that is an universal law. It is applicable irrespective of the functional group. Okay, next coming to boiling point. So what happens? Now the boiling point depends on hydrogen bonding, right? Intermolecular force of attraction. So if you see, I have two amines. So just let me think like some NH2 is there. Okay, and I have one more. Okay, so here one bond will form. Okay, then we have here this can bond. So there is intense hydrogen bonding between the two compounds. Okay, so there is two hydrogens are there, right? So more intense hydrogen bonding will be there. So that is why primary amines will have higher boiling point than secondary and then tertiary. Clear? So this was about your physical properties. Okay, now we'll start with the chemical properties. So I think this one I have already discussed. Okay, so under basic nature first we'll discuss, then alkylation, then acylation. After that I have carbyl amine reaction, then I have reaction with nitric acid, benzene sulfonyl chloride or with aryl sulfonyl chloride, then electrophilic substitution reactions. Okay. Next we have here basicity, gaseous phase and aqueous phase. This is a must question, very important, remember. So what is exactly basicity? Now basicity means when you have one amine group, okay, RNH group. So if you have a amine group or a lone pair of electrons, the tendency of this amine to donate electrons is called as basicity. Okay, tendency of an amine to donate electrons is called as basicity. Okay, now what happens here? See, when this R group are present, okay, the tendency of the amines to donate electrons is called as basicity. Now what I am saying is, now suppose you have more R group. Okay, what is the tendency of R group to donate electron? How? By plus I effect. So this electron density on the nitrogen will increase, so the tendency to increase will increase. See, suppose I'll give you a simple example. I have some money, okay, I want to donate or I want to do some charity, I want to donate to some beggar or something. Now for that, suppose my mother also gave me some money, my father also gave me some money, my brother also gave me some money, so I have more money now, I can donate more money, right? Just imagine. Now suppose in that same case, if I have like I have an younger brother, okay, for example, and suppose he is younger to me, he can't donate me. Okay, so now in that case what will happen? If nobody is giving me, I will have less to donate. Okay, if my parents are also giving me money to donate, then I will have more amount to donate, right? So the same thing is happening here. What happens? These R groups, okay, they donate electrons to the nitrogen, so nitrogen has more electrons to donate, right? So that is why its basicity will increase. Okay, but in case of this R group, suppose they are hydrogen groups. So suppose my parents are like very selfish and they don't want to give me any money. They are saying like, okay, you are earning, you give, we don't have money to give you. Okay, for example. Okay, they suppose my parents are saying like this. Okay, they are saying we won't give you any money. So whatever salary I am getting, whatever money I am having, I can donate only that much, right? There is no support for me. Okay, so comparatively, suppose you are suppose one person, this is one person. Okay, I am making 3 antennas. So in this person, father, mother and brother all are giving money to this person to donate to some poor person, but here father, mother and brother are not giving any money here, right? So who will have more money to donate? This person will have more money to donate, right? Same thing is happening in amines. I hope that all of you have got what is basicity. Okay, so that is why in gaseous phase what happens in tertiary group, you know, okay, in tertiary group, if I just do tertiary one, so I have N. So in tertiary 3 R groups are there who are donating electrons to nitrogen. In secondary what happens? There are 2 R groups, okay, and they are donating electrons to the nitrogen. In primary there is 1 R group and we have, okay, this is there. Okay, so now you see where there will be more donation here, because 3 persons are donating electrons or 3 groups are donating electrons. So that is why this is the order: tertiary, secondary and primary. Okay, now what happens in aqueous phase? There is some other factors also involving. In aqueous phase we have what all the factors that are determined in aqueous phase. You have solvation effect, okay, you have steric effect, and you have also inductive effect. Okay, so now when we combine these all effects, then we can tell you that the order in aqueous phase is different. For ethyl group it is 2 degree, 3 degree and 1 degree. For methyl group it is 2 degree, 1 degree and 3 degree. Clear? So that is about the basicity. Now talking about aryl amines and ammonia. So if you see aryl amines means your aniline. Okay, so aniline is very poor person. Can you say why? See, this group, suppose my parents are there, okay, I want to donate, but my parents are very poor, they also want my money from me, they are like dependent on me, for example. So what I'll do, I have to give them also, then I will have very less money to donate. Okay, so same thing happens with aniline. The friends or the family of aniline, okay, we'll call this as a family of aniline. So the family of aniline is dependent on nitrogen. Okay, so whatever nitrogen has, they want that only. Okay, because they don't have there any other source, so they are dependent on nitrogen. So nitrogen cannot donate here because its electron is involved in the welfare of its family. I hope all of you are getting this concept. You can imagine what is happening here. Right? Okay, fine. So that is why what happens if I consider nitrogen, ammonia. Okay, so suppose like my parents are there, okay, they don't want money from me, they are not giving me money. So I will have some, okay, whatever I am earning, I don't have to give to them, they don't have to give to me, I will give something. But if they are dependent on me, I have to give them also, then I will have very less money for donation, right? The same thing. In case of ammonia, these hydrogens are like, they don't want, they won't give. Okay, so they won't take, they won't give. So this nitrogen has something to donate. But this one, this family of aniline of this nitrogen are taking electrons from here, so it cannot give. Okay, now if you have very like what I'll say, when one R groups come, okay, generous family member, he is giving to this one. Okay, so when this person is donating this nitrogen, basicity will increase. Okay. Next, coming to the second, okay, here's a question: the strongest base among the following. Okay, so wherever you find this one, benzene ring, okay, it is a one which is pulling electrons from nitrogen, so it is not a strong base. Here also I can see, here also it is not there. Yes, but if I see here, the C and D, see one H is there, okay, and here I can find C2H5 groups are there. 2 C2H5 groups are there. Okay, now this one will donate, this one will donate, so basically here will be more electrons to be donated, right? So that is why this one will be more basic. Okay, option number D will be the correct answer here. Okay, next, the decreasing order of basic characters of 3 amines and ammonia. Okay, so this is like in gaseous phase if nothing is mentioned. So what we can find, okay, basic nature, right? Okay, so you see here, first of all, C6H5NH2 has to be the lowest one, because these were, they will withdraw electrons from this one, so we can eliminate these two options. Now after that, there has to be ammonia. Okay, next after CH3NH2 and C2H5NH2, C2H5NH2 has more carbon, so it will donate more. This has less carbon, so this will donate less. So option number B will be the correct answer here. Okay. Now moving to the next question, next part, that is your chemical reaction. So after basic nature, we have the alkylation, right? So for alkylation, what we have, reaction with, so this is your second one, that is alkylation. Very simple. What we have to do here, you have RNHR. Okay, so when you are treating it with Rx, this H is replaced with R. Okay, so sorry, one second. So when you have RNH2 and you are reacting with Rx, so that the ammonolysis process only, H is replaced with R, so you get a secondary amine here. Okay, now again if I react with Rx, this H will also get replaced and we'll get tertiary amines. So for alkylation, simple, you have to treat it with ammonia. Okay, next coming to acylation, the second part, here what happens, one of the H is replaced with COR, RNHCOR. Okay, RNHCOR. This is what? Third one, that is acylation. Okay, next fourth one here also, that is your acylation only, but we can do acylation using two different reagents. One is RCOCl, one is your anhydride. Here also this H will be replaced with COR. Okay, NHCOR from here. Okay, this is also part of acylation. Next, here also we can do, there is something, if you take benzene ring, okay, then it is called as benzoylation. When you add the benzene group to H, replace H with COC6H5 group, that is called as benzoylation, but it is very much similar to acylation. Okay, but only thing is it is a benzyl group attached. Okay, next coming to your carbyl amine test. So here also something very important I have to tell you, and I know most of you might be knowing that as well. This test is used as a test to distinguish or to identify the primary amines. Okay, how will happen? Only the primary amines will react with this CHCl3KOH to give you RNC. What is this RNC? It is a isocyanide compound. How can we know? It will produce a very bad smell, or I can say foul smell. Okay, so if you take primary amine and react with this one, okay, you will get isocyanate compound, because of which a foul smell will come, and you can easily guess, okay, this is a primary amine. Okay, so first was basicity done, second one was alkylation, acylation. Okay, next one is your this is fourth one, right, carbyl amine. Next was reactions with HNO2. So here also very different things are there. Two important things. If it is an aliphatic amine, if you react with nitrous acid, you will get ROH, that is alcohol. But if it is an aromatic ring and if you react with HNO2, you will get N2 plus Cl minus, that is your benzene diazonium chloride. Okay, now moving to next one. So this is which one I got here? Fourth. This is fifth one, right? Sixth one was what? Yes, benzene sulfonyl chloride. Okay, so here something you should remember, this is your benzene, okay, sulfonyl chloride. Okay, and this is also called as Hinsberg reagent. Okay, it is also called as Hinsberg reagent. Now if you have this one benzene SO2Cl plus HCl, you have RNHH. Okay, now this HCl will go, so what you will get? You will find this compound, right, NHR. Now similarly if you react with so now what happens, this group, okay, this is having one acidic H. Okay, so this will react with alkali. So what exactly is happening? This HCl is removed and this one is connected to this one. Now here this H is acidic, so what happens, this salt or precipitate is soluble in alkali. Okay, now if I take a secondary amine, so what I will get, so I haven't given, suppose primary amine, I mix this Hinsberg reagent, one precipitate is formed, after that I added some alkali, that precipitate will dissolve, so I can guess that this is primary amine. But if I take a secondary amine, I will get a precipitate will form, but here you see there is no acidic hydrogen, so it is insoluble in alkali. Okay, now the third one, here you see for this reaction to happen, one H should be present with nitrogen, but here there is no H, so that is why here there will be no reaction. Okay, that is your benzene sulfonyl chloride reaction or Hinsberg test. Okay, now coming to something which one? Okay, electrophilic substitution will go next, last reaction. So amines, okay, this NH2 group is a highly activating group. Okay, so what happens if you directly treat bromine water, like you have studied in phenols group? Okay, so what will happen? All the positions will be occupied. But if you want to get only ortho and para product separately, so here first of all you should be knowing that it is a donating group and it is ortho and para directing. Okay, now HNO3 and H2SO4 if you treat directly, okay, so what will happen? Here you get three types of product. Okay, one you will get para product, you will get ortho product, and you will get meta product also. What is something which is exciting here, interesting here, different here is getting meta product. We have been studying from long that whenever we have electron donating group, we get ortho and para product only. But why then meta product is formed here at that too in such a large amount? That is because what happens, this nitrogen, this H plus is present, and you know the lone pair of oxygen and nitrogen are very notorious, right? What they will do, they will immediately catch wherever they get H plus. So they take this H plus. So after that, what is this structure formed? You will get a structure like this. Okay, so now this group becomes electron withdrawing group. Okay, now if it is electron withdrawing group, where will it direct anything? It will direct to the meta position. So that is why we get enough amount of meta product as well. Okay, now what happens? Yes, if you treat with H2SO4, this one again the same thing happens. You get one salt is formed, then if you heat it, there is a proton exchange, and finally you get NH3 plus and SO3 minus for sulfonation. Okay, now suppose I just want to get only one bromine, okay, not this three types of bromine I don't want. So what you have to do, you have to make this NH2 group less active, or you have to deactivate it. So for that purpose we use CH3CO with pyridine. So what will this do? This will convert this NH2 to NHCOCH3. Okay, now if you do HNO3 and H2SO4, you will get only para product, and then if you just treat it with OH minus, you can get back your NH2 group. Okay, similarly you can first you can protect that. You can use bromine with CH3COH, then you will get bromine only in the para position. Then you can remove this OH minus and get bromine only in the para position. Okay, so that was all about the electrophilic substitution reactions of aniline. Okay, fine. Now let us go back here. Okay. Yes, now see, if it is basic nature, okay, so what happens in basic nature we know. Let me just revise it. For alkylation, what we have to do, we have to treat Rx plus NH3. For acylation, what we have to do, you can use CH3COCl, you can use CH3 double bond O, C double bond O, CH3. For carbyl amine reaction, what you will get? You will get RNC. Okay, carbyl amine reaction, for RNC you can react with CHCl3 plus KOH. Okay, next with nitric acid you will get HNO2 if you react. For aliphatic one you will get alcohol. For phenol you will get for aniline you will get benzene diazonium chloride. Sulfonyl chloride we have discussed, nitration, sulfonation and halogenation. Okay, so these are all the chemical reactions of this one. Let's do some questions so that we can just refresh what we have studied. Ethylamine reacts with nitrous acid to give you. So I told you if it is an alkyl amine, it will give you alcohols. If it is an aryl amine or aniline, it will give you benzene diazonium chloride. So this one will give you ethyl alcohol. Okay. Next, when ethyl amine is heated with chloroform and alcoholic KOH, a bad order compound is formed. The compound is, so I have already discussed you, primary amines will react. This is called as carbyl amine reaction. Okay. Next one we have here compound which does not react with CH3COCl. Okay. Primary, secondary, tertiary, all of this. So now see, if the molecule is much hindered, reaction will be less stable. Okay, reaction will be less here. So that is why option number C here. Okay, because of its steric hindrance, or such a big compound is there. So it becomes difficult. Fine. Now we will move to, yes, yes. So these are next topic, that is about benzene diazonium chloride. Okay, benzene diazonium chloride. Okay, benzene diazonium chloride. So we will be studying about the preparation, about the physical properties and the chemical properties of benzene diazonium chloride. What is this benzene diazonium chloride? The structure is like this, and you won't believe this is such a useful compound. Okay, you can prepare anything using this one. This is your Brahmastra. Okay, you can do any of the reactions if you have this particular compound. But the problem with this is this compound is very less stable. Okay, so first we'll see preparation. Physical properties are very small, chemical properties are little important. Okay, so first of all, you can prepare directly with taking aniline, NaNO2 and HCl. This temperature you can see, what's the temperature? 0 degree to 5 degrees Celsius. Okay, at such a low temperature it is stable and it is formed. So that is this C6H5N2 plus and Cl minus. Okay, fine. Now coming to the next one, the properties colorless and they are soluble in water. Chemical reactions are very important. Okay, yes. So now see, chemical reactions are, again we have divided into two types. So first one is what? First one is reactions involving the displace of N2 group. Okay, so that N2 group will go, in that place some other element will come. So for example, replacement by Cl minus or Cn minus, replacement by I minus, replacement by F minus, replacement by H, replacement by OH, replacement by NO2. So we have six reactions. What is the reagent? So you should be knowing what is the reagent to replace this Cl minus, what is the reagent to replace this Cn minus, to replace I minus, F minus, H, OH and NO2. And apart from that we have coupling reactions as well. Okay. So let us see first one. First one was what? Replacement with Cl minus and Cn minus. So you can see here you have this one Cu2, Cl2 and HCl, Cu2, Br2 and HBr, CuCN, KCN. So if you use this one, you can replace Cl. Okay, now see, what you will get, this N2 will be replaced with Cl. You will get chlorobenzene. Here this will get bromobenzene. Here you will get cyanobenzene, okay, or CN benzene. So this type, if you are using copper salts, okay, then we call it Gattermann reaction. Okay, let us see the reactions now. So you see, if you want chlorobenzene, bromobenzene or cyanobenzene, and if you are taking copper salt, okay, Cu2, Cl2, Cu2, Br2, CuCN, if you are using copper salt, then this is called as your Sandmeyer reaction. Okay, remember, salt is there, then Sandmeyer, SS. Okay, I also discovered this right now. So I also get confused with Sandmeyer and Gattermann. So if salt is there, okay, then it has to be Sandmeyer reaction. If only metal is there, copper HCl, copper HBr, you see this copper, with copper there is no salt, it is pure copper metal. So in that case it is called as your Gattermann reaction. Clear? So first one, to replace chlorobenzene or bromobenzene or to get cyanobenzene, you can use either Sandmeyer reaction or Gattermann reaction, the first one. So there were 6 replacements, right? This is the first one. Second one, if you want to replace with iodine, simply what you have to do, treat it with Ki, you will replace with iodine. Okay. Next, coming to replace with fluorobenzene, you can treat it with HbF4. So what is here? See, H plus and BF4 minus. So N2 plus will react with BF4 minus. So we will get this one Ar N2 BF4 minus. After that you have to just heat it. To heat it, what you will get, ArF will be there, okay, and nitrogen group and BF3 group will be produced. Okay. So you can see here, one of the fluorine comes here, nitrogen goes out and we get BF3. Okay. So this is your, what I will say, this is the third one. Okay. Third one for getting fluorobenzene. Next, coming to if I want to replace it with hydrogen, so it will be either H3PO2 and H2O. You have to use H2O or H3PO2. Okay, sorry, no, sorry, not either. It is like H3PO2 in presence of water. Okay, so that will do what? You will get only benzene. Okay, H3PO2 in presence of water, that will give you benzene. Okay, this is your fourth one. Now, if I want to take only hydrogen, that is the same thing. You can also use ethanol. Okay, so both are possible. You can use H3PO2 in presence of water. You can use ETOH. Both will give you benzene. Now, if I want a phenol group, okay, so that will be, if you add just water, you will get OH group. Okay, phenol group can be produced here. Now, for the sixth one, you have here, yes, HbF4 you have N2 plus and BF4 minus you will get. Next, if you heat it with NaNO2 and copper, okay, NaNO2 and copper, and if you heat it, you will get NO2. Okay, so you will get here NO2 group. Clear? This one will give you NO2 group. So that is how you can replace N2 group with NO2. So here first you have to take the same step you have to do. After that, this you have to remember NaNO2 Cu and heat will give you NO2 group. You can remember because NO2 group is here, NO2 group is here, right? So I am very sure that you would have understood all these replacements. Let us do this quickly. For Cl and Cn minus, what all things I can do? So if I want Sandmeyer reaction, I can use Cu2Cl2 HCl, or I can use Cu2 Br2 HCl. Okay, or if I want Gattermann reaction, what I can use? CuHCl, or I can use CuHBr. Okay, for iodine I have to simply use Ki. For fluorobenzene, first I have to use HbF4. Once this is formed, I have to heat it, right? Let us check HbF4. After that, you have to heat it. Next is, if I want replacement by hydrogen. So for replacement by hydrogen, there were two things. One thing, I can use H3PO2 in presence of water, or I can use ethyl alcohol. Okay. Next, for replacement with OH, simple thing, water. For NO2, first you have to use HbF4. Okay. Then you have to use, okay, what is it? NaNO2 in presence of Cu. See, I am also trying to remember with you. Okay, clear? So these are the things that we can do to replace the N2 group. Now coming to coupling reaction, there are two types of coupling reaction. One is benzene diazonium chloride with phenol group. So in this, what will happen? This HCl will be gone or will be removed, and here there will be one couple reaction form and one OH will be attached. So that is called para hydroxy azobenzene. Okay. Now similarly here what happens? You get this one, and here HCl will be removed. You will get NN double bond. Okay. Then NH2. This will give you para amino azobenzene. So you know this para hydroxy azobenzene is orange in color and para amino azobenzene is yellow in color. Okay. This is orange in color and this is yellow in color. Clear? Fine. Next, coming to this one, the correct sequence of reactions to convert para-nitrophenol into quinol involves what? Okay. So if you have para-nitrophenol, okay, para-nitrophenol, and see, how will you know the structure of quinol? Phenol, when I discuss alcohols, phenols and ethers, I have discussed what is quinol. What is actually quinol? Quinol is two OH groups at para position. So basically you have to convert this NO2 group to OH group. That will happen if you have aniline here, right? So first of all, I can convert NO2 to what? I'll do reduction. Okay, first we will do reduction. So we will get what? NH2 here. Once after that, if I do diazotization, I will get what? N2 plus and Cl minus. After that, hydrolysis means treating it with water, I will get this one, OH group can be attached here. Okay, very simple question this one. Yes, next, the reaction of benzene diazonium chloride with aniline yields a yellow dye. The name of the compound is, we have just discussed, para amino azobenzene. Option number B. Remember the color also. For azobenzene it is yellow and for hydroxybenzene it is what, orange in color. Okay, so yes, that's all students in this class. I hope that this lecture would have helped you to complete revision of all the reactions. You would have done the flow chart, and please let me know in the comment section whether you enjoyed this or not. And this, remember, this series is going to be very, very effective, and this is your one-stop solution if you are preparing for KCET. We will also be solving questions. Everything is available. So students, please study hard. Share this video, like this video, share with all your friends, and let's work together. Let's put all our efforts together to get a top 1000 rank. Okay, so all the very best. Keep studying till you get your dreams. So all the very best. Keep working hard till you get what you want.